And ladies and gentlemen, this is a great and wonderful Wednesday morning, April 22nd. So, we're going to continue talking about radicals today. Remember, yesterday we talked about how a radical and a root are roughly the same thing. We often say that square roots are that symbol, and radicals are just the general form. It could be more than a square root, it could be a third root, a fourth root, an nth root, whatever. Specifically, this one is an nth root. And today we're going to talk about how radicals and exponents share a very direct relationship. How, even though they look like and they operate like opposite operations, they can be interchanged back and forth depending on what context you want to use them in. Like, if I have something to the nth power, m is my exponent, and n is my index, well, if I wanted to write that as an exponent, m stays as my exponent, but n now becomes a denominator and a rational exponent. Remember, rational means any number that can be represented as a over b, or in this case, m over n. So, fractions. All fractions are rational numbers. But I do want to re-emphasize that m is always going to be your exponent, and it's in your index that becomes your denominator. M is always the numerator, n is always the denominator. So if I have something like this, the fourth root of x to the third power, well, that 4 is simply going to come over to the other side, going to get into the denominator, and it's now x to the 3/4 power. Instead of the fourth root of x to the third, it is x to the 3/4 power. And the same thing can happen in reverse. If I see that I have a 4 in a denominator, well, guess what? That's going to come over here into a root and be a fourth root. Pretty direct and pretty straightforward. So if I have something like this, I see, oh hey, this 9, well, that's just going to be a 9. It's just going to stay in the same spot. It's an exponent, it's going to be a numerator. But this 3 is going to come over to the other side, and it's going to be now x to the 9 over 3. Now, ladies and gentlemen, in this case, always simplify your exponents. What's 9 divided by 3? Well, 9 divided by 3 is 3. So the third root of x to the 9th, well, it's 3. Or x to the third. Oh, went a little too far there. Now if we see something like this, okay, well, I don't see a number there. What are we supposed to do? I don't see a number there. Well, if you remember what I said yesterday, if you don't have a number there, the lowest thing it can be is a 2. So that's now 16 1/2, and then x, I just gave it away, to the 10 over 2. They might say, oh, Mr. K, what's going to be the number up here? Well, it's a 1, because if you don't see an exponent, always assume the exponent is 1. So this is definitely x to the 5th. But what's going to be that 16? Well, anything to the 1/2 power is the same thing as a square root. So admittedly, it's still a square root of 16, which means it's 4x to the 5th power. Moving on. Check for understanding. Pause the video, wait 5 seconds. But I want you to turn each one of these radicals into exponents and turn the exponent form into a radical form. So, take 5 seconds. We are going to kind of breeze through the stuff today. I do have to get to an online meeting, which isn't going to be pleasant. Alright, so, remember, index always becomes the denominator, and if you have an exponent, if you don't see an exponent, it's always 1. So we know that's x to the first power. So that's, obviously, I'm just rewriting the same thing, but I'm putting it where I can see the 1 better. 1 over 21. Now, for the exponent into radical form for number 2, the 15 doesn't change. For the exponent, the 15, the numerator, it doesn't change. It's still your exponent. But the 12 goes to the other side, because it is the index. And so this is the 12th root of x to the 15th power. Now you couldn't simplify any of these, but we do what we can. But that's pretty straightforward. Alright, one important thing that I want to talk about, if two expressions that are either being multiplied or being divided, if they share the same type of radical, you can combine them into one. Meaning if they're both square roots. If you have two square roots, if you have two cubed roots, you can combine those. If you have two 15th roots, you can combine those. And I'm not talking about adding them or subtracting them. I'm meaning you can put them in the same multiplication or you can put them in the same division. So if I've got something like this, square root of x times the square root of x to the 3rd power, I see that these are both a square root. They're both square roots. They both have an index of 2, meaning if they share the same type of radical, they have to have the same index. If they have different indexes, you can't do anything with them other than just carry the normal operation out normally. So this is the square root of x times x to the 3rd. Now, when you multiply x and x to the 3rd, what do you do with the exponents? You add them. Because remember, when you multiply variables, you add exponents. So that's going to be 1 plus 3. Well, that's the square root of x to the 4th. Now what's the square root of x to the 4th? That's very wide for x squared. Now let's look at this one. This one looks like a division problem, but guess what? We're going to treat it the same way. If I see that, oh, these are both the 5th roots. Awesome, totally fine. I'm going to combine them into one. The 5th root of x to the 20th divided by x to the 5th. That's one operation. Now, if you multiply variables, that means you add exponents. What does it mean when you divide variables? That's right, you're going to subtract exponents. That means this is the 5th root of x to the 20 minus 5. What's 20 minus 5? 15. Alright, ladies and gentlemen, same thing as last time. I want to simplify this problem. So I take that numerator, I take this index, and it becomes my denominator. So I have x to the 15th over 5. So what's 15 divided by 5? 3. X 3rd power. Now I do have a third one here. Oh, so I have x squared, x to the 3rd power, you might think, and I do have another problem. You might think, oh, obviously that's going to be x to the 4th, that's the next pattern. Not quite. Ladies and gentlemen, what's different about this? This has an index of 3 and that has an index of 4. Because they don't share the same index, I cannot combine them into a single expression. Can't combine them into a single expression. Meaning I would have to figure out what y is first, then do y cubed and y to the fourth, and then take the third root, and then take the fourth root, and then multiply them. There's nothing that I can do to simplify this. I can only keep it as it is. And I don't know what y is. So, excuse me. To recap, if two expressions share the same type of radical, meaning that they have the same index, they're both square roots, they're both cubed roots, they're both fourth roots, they're both 21st roots, it doesn't matter. Then I combine them into one expression. Makes it a little bit more simplified. Like the square root of x times the square root of x cubed, that's the same thing as just x squared. This just becomes that. And that's a little bit simpler than having to square root this, and then cube that, then square root that, and then multiply. No, it's just x squared. It's more simple. Alright. I got these. If you look at these, you might say, hey, I can't do that. One has an x to the 7th, the other one has an x squared, and then y cubed. It's actually not a problem. Because they share the same radical, you can just put them in the same thing. 12th, x to the 9th, because what's 2 plus 7? It's 9. And the y, well, there's no y over here, but I'm just going to assume there's just a 1, and 1 times y is just going to be y cubed. So, simplify this, because you should always simplify. Or let's put this into an exponent. Oh, look, I've got a little co-star who's wanting to show her face. Come here, girl. Ah, little co-star. Pretty little girl. Yeah, she's a pretty little girl. Alright, I'm going to put you down right here. Alright, so if I want to put them into an exponent form, well, that'd be x, that's x, and then y, which becomes x to the 3/4, always simplify, y to the 1/4. She is just staying right here. And there she goes. Alright. Same thing with this division. That becomes x to the 4th power, x to the 21st over x to the 3rd. What's 21 minus 3? X to the 18th. Oh, kind of wrote the same thing over and over again. I love my cats. 18 over 4. Unless I want to get a decimal, I'm going to keep it like that. And I don't want to get a decimal. So these are my two answers. Now, ladies and gentlemen, I won't be doing a video tomorrow morning, so I will, however, be doing a video Friday morning. It's going to be something a little bit different than this. But ladies and gentlemen, it's been fun. I hope you guys have learned something. Once again, stay safe, stay inside, and hope you guys have yourself a wonderful Wednesday